Wellsite Geologist Operation Procedure. The Wellsite Geologist is the key link between the technical operations on the drilling rig and the geological team at the head office. Pond job description: the eyes of the well. The Wellsite Geologist serves as the primary representative of the operator's geological department at the rig site. Their core mission is to ensure that the well is drilled into the correct geological targets while maintaining a detailed and accurate record of the formations encountered. Objective: to minimize geological uncertainty and maximize the quality of data collected. Key interface: they act as the bridge between the drilling supervisor, company man, the mud logger, and the office-based exploration team. 2. Duties and responsibilities by phase. The role changes significantly depending on the stage of the drilling operation. A. Pre-drilling phase. Data review, study offset, well logs, seismic data, and the geological prognosis. Preparation: ensure all logging equipment, chemicals, and sample bags are ready. Briefing: coordinate with the mud logging crew regarding sampling intervals and expected markers. B. Drilling phase B. Monitoring, track real-time drilling parameters, ROP, gas, WOB. Sample analysis: describe drill cuttings and evaluate oil shows. Correlation: compare current depth findings with the prognosis to predict formation tops. Reporting: issue daily geological reports, DGR, and update the master log. T-post: drilling phase. Wireline supervision: oversee wireline logging operations and QC the data. Wireline supervision: oversee wireline logging operations and QC the data. Core management: supervise the handling, labeling, and shipping of core samples. 3. Cuttings and oil shows description. This is the bread and butter of a WSG. You must be precise to avoid misleading the engineers. A. Cuttings description. Lithology: identify the rock type, e.g. sandstone, limestone, shale. Physical props: color, hardness, indurated, friable, and grain size using the Wentworth scale. Texture, sorting, rounding, and matrix cement type. B. Oil shows evaluation. Odor: check for petroleum smell in fresh samples. Staining: observe the percentage of the sample covered by oil. Fluorescence: place samples under UV light. Note the color, e.g. bright gold usually indicates light oil. Dull brown indicates heavy oil. Cut: add a solvent like chlorothene to the sample. Observe how the oil bleeds or streams out. 4. Lithology characteristics. Lithology characterization is the process by which a geologist identifies and describes the physical properties of rock formations during well drilling. It is critical for identifying formation tops, determining reservoir potential, and ensuring drilling safety by providing real-time subsurface data. 5. Casing shoe position selection. The casing shoe is the bottom of the casing string. Selecting its position is a critical safety and engineering decision made by the geologist and drilling engineer. The goal: to set the shoe in a competent, impermeable formation, like a thick shale, to provide a strong seal for the next drilling phase. Selection criteria: avoid high pressure. Never set a shoe directly above a high pressure zone. Avoid losses. Avoid fractured or highly porous zones where cement might leak away. Integrity: perform a leak-off test, LOT, after setting to ensure the formation can handle the mud weight required the next drilling phase. Target: Depth, usually set just before entering a new reservoir or a known trouble zone.